All right, here we are. Problem number 20. I believe, I'm not sure. Let's see, we got 4 marks, 2 marks, and then part C is 2 more marks. So it looks like an 8-mark question. So not often that you see an integrating factor question worth only 8 marks, but that's okay. There might be a twist. We'll see what happens. So part A, using integrated factor, show the general solution for dx dt minus x over t is equal to negative 2 over t is x equals 2 plus ct, where c is a constant. Okay, so they're giving you the answer. You just got to work your way there. So integrated factor, remember, is if things are in the form y prime plus p of x y equals q of x, right? In this case, it's not a function in terms of y and x, it's a function in terms of x and t. So we want x prime, which we have, dx dt, plus p of t times x is equal to q of t. Okay, so p of t in this case going to be equal to negative 1 over t, and q of t is negative 2 over t. Okay, so integrating factor method, we've got exactly what we need right now. Okay, so knowing p of t and q of t, I can find I of t. Remember, I of t is e to the integral of p of t, or p of x. So it'll be negative 1 over t dt. That's telling me that I'm going to get e to the negative ln of t. Remember, no plus c in this case. The only time you'll ever not have a constant of integration. This is equivalent to e to the ln of 1 over t. Okay, therefore I of t is equal to 1 over t. All right, so now remember we do d dt of y times I of x, or in this case x times x of, I of t, which is 1 over t, is equal to the integral, is equal to I of t times q of t. So that'll be 1 over t times negative 2 over t. Okay, so we will get ddt of x times 1 over t, which was I of t, is equal to negative 2 over t squared. All right, now integral both sides. The left side, take the integral of a derivative, it just comes out to be said thing. On the right side, I'm going to take the integral of that, which will end up being 2 over t plus c. And then to get x alone, I multiply both sides by t. That gives me 2 plus ct. Exactly what we're looking for. C.T. Fletcher would be real impressed right now, although he would probably still scream at you for some reason. All right, 20b. Given that w of t is continuous, find the value of c. Now w of t, I'm going to translate here. I'm going to pause the video and translate it down here. Okay, so as we look at w of t, we get 2 plus ct, okay, the weight of in kilograms of the dog, right, is w of t weeks after being bought from the shop. And it's modeled by this. So for the first 5 weeks of the puppy's life, its weight would use this function, and then after 5 weeks, its weight would be determined by that function. So given that wt is continuous, find the value of c. So if continuous, then the limit as t approaches 5 from the left, which would be 2 plus ct, must be equal to the limit. This is if it's continuous, as t approaches 5 from the right, which is this. And those limits evaluate out to 2 plus 5c. And this limit would evaluate out to 16 minus 7, which is 9. Okay, I just plug in a 5 for t, and I evaluate. Now I can find c. So it looks like c will equal 9 minus 2, which is 7 over 5. So there is our constant for the differential equation we had put together on the previous part of the problem. Let's finish this one off in part C. Okay, determine, or write down, because I was just going to think about it and not write it down. Determine the weight of the dog when purchased from the pet shop. Oh boy, I don't know how many people buy a dog at 0 weeks old. Let's see if it's just, if they actually determine if this is, okay, T weeks after being bought from a pet shop. Okay, so week 0 could be an 8-week-old puppy. Good, because nobody buys a puppy right as soon as it's born. The heck. All right, so the weight of the dog when purchased or bought from the pet shop. Well, that would be equivalent to W at 0. Okay, and W at 0 would be T equals 0. And of course, that occurs in the first part of the piecewise function, which was 2 plus, I don't even care, whatever, I can't remember, what was it? Oh yeah, 5C. 5C. Wait a minute. What the heck? Oh yeah. That would be at 5. Oh boy, this turned out awesome. And that's a highlighter, not an eraser. I hope you guys are enjoying this. This is really funny. Okay, I'm gonna scratch this. Okay, 2 plus 7/5 T. Cool. T weeks after being purchased. So in for T, I'm going to plug a 0, which clearly makes that 0. So the weight at the purchase is 2 kilograms. Cool. All right. Do you forgive me? Thank you. All right. Let's find the upper bound for the weight of the dog. So the upper bound for the weight of the dog. There's a lot of assumptions there, but based on this function, we would take the limit as the dog's age in weeks approaches infinity. Healthy dog must take supplements, which is 16 minus 35 over T. As T approaches infinity, the second expression in that will go to, or the second term will go to 0. Therefore, the dog's weight as it approaches its adult years would be a max upper bound of 16 kilograms. Okay, guys, integrated factor with a little bit of a twist. Pretty doable, though. 8 marks, I think it was, that are very accessible. So, again, shoot the questions if you got them. Have a good day. Take your vitamins.